Moles to particles and back again, a chemistry student's tale. Alright, our last section, we're going to combine all the parts together. So we've already converted atoms and molecules into moles, and we've converted mass, grams, into moles. So now we need to put those two parts together to answer questions that might look something like this. If there's a student who measures out 257.43 grams of calcium carbonate, how many molecules will they have measured out, he or she? Right, so example 1, we're going from grams to atoms in this case, right? We're given grams here in the question. It's a conversion problem. Like the other ones we did when we went from moles to atoms or moles to grams. It's conversion, but we have, in this case, more than one step. So we're going to start by using what we're given. So we're going to take out 257.43 grams of calcium carbonate, put it in the top of our conversion chart, and we cancel our units. So at 257.43 grams of calcium carbonate. The of isn't written, it's implied, but make sure you have both units. So the grams and calcium carbonate, they're both really important. I want to be a stickler on quizzes and tests, and you want to make sure they're both in there, because you just say, go get me 50 grams of what is really important. So the grams of calcium carbonate. Which means when we cancel this unit in a minute, both the grams have to go down here, and the calcium carbonate has to go down here. So we're going to cancel the grams of calcium carbonate, and we know that that's equal to a mole. Where we got this 100.09 grams from, that's the molar mass of calcium carbonate. So 1 mole of calcium carbonate weighs 100.09 grams. So we get from adding up calcium from the periodic table, carbon, and oxygen, all rounded to 2 decimal places. Make sure you get the same number when you're doing it. We cancel grams of calcium carbonate. Both the units cancel, but not the numbers. Okay, then we need to cancel moles of calcium carbonate. This one looks identical because calcium carbonate will cancel in moles. That's equal, a mole of anything is equal to 6.02 times 10 to the 23rd molecules, or atoms, but in this case it's molecules because we have more than one atom together. So our moles of calcium carbonate will cancel. We're in molecules of calcium carbonate, which is what he's looking for, is how many molecules. Even though the question doesn't say molecules of calcium carbonate, you still need to put that in your answer. Both the molecules part and the calcium carbonate part. You can skip the of if you want, you can put it in there if you want, either way is fine. Then we just do the math. Take 257.43 divided by 100.09 and multiply by Avogadro's number, 6.02 times 10 to the 23rd, and we get 1.55 times 10 to the 24th molecules of calcium carbonate. It's a lot of molecules, but that's what we get. Okay, example 2. Now we're going to go the other direction. So we have 3.56 times 10 to the 22nd atoms of KBr. We're trying to figure out how many grams we'll need to measure out to get that many. So like in our last one, we're still going to start with what we're given. But in this case, we're given 3.56 times 10 to the 22nd atoms. Oh, that's not right. That should be molecules. There's a typo, but it's good down here. So molecules of KBr. Ignore this. Molecules of KBr, we need to cancel that whole unit. So molecules of KBr is going to come down here. Molecules of KBr. We can turn molecules of anything into moles. So moles of KBr will be on top. Our molecules of KBr need to cancel. Now we're in moles, but look at our question. We don't want moles, we want grams. So moles must cancel, which means it's going down to the bottom right of our conversion chart. Moles of KBr cancels. We're going to turn it into grams. That grams per mole, grams divided by moles, that's its molar mass of KBr. So you add up potassium's molar mass in the periodic table and bromine's mass in the periodic table, adds up to a perfect 119. Then we do the math. 3.56 times 10 to the 22nd divided by Avogadro's number times 119 gets us an answer of 70.37 grams of KBr. All it is just combining the two parts we've done together into one longer two-step process. Hopefully it's not too challenging. If so, if this is making sense, give it a shot with these. Go ahead and hit pause, give it a shot, then we'll go through and show you how it's done. Okay, hopefully you've got answers. Number 1 is asking how many grams there are in 2.3 times 10 to the 24th atoms of silver. You should get 412 grams of silver. Second one, you should get 1.6 times 10 to the 24th molecules of NO2. The last one should be 195 grams of BCl3. If not, check your work, ask me questions if you're with me, or post comments down below. See you all soon.